I can't see check out.
Uh-oh, uh-oh, something's wrong. The front row can't see the monitor. Let's see, we got the video going already. And we'll just solve 2 or 3 problems without it and come back to it later.
Yeah, we can.
Yeah, that'd be all right. Okay. Well, you probably don't remember, but there was a time when we had thetas, and then we had sines, cosines, and tangents. And we said 30 degrees, 45 degrees, 60 degrees, 90 degrees.
Hey, guess what?
But the front row's being picky again. They want the right monitor to be shown. And we said that, oh, we also have 0 degrees, so we'll have to do it all over again. Okay, well, I'm glad that you're pleased now.
Thank you.
So we have 0, 30, 45, 60, 90. And we said this is 0, 1, 2, the square root of 0, the square root of 1, the square root of 2, the square root of 3, the square root of 4, over 2, over 2, over 2, over 2, over 2. Okay, and that's our memory aid for remembering first quadrant sine. And then once we remember that, then we write down 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. And then cosine just goes the other way. 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0. And then tangent just goes, tangent is just sine over cosine. So once we have that written, then we remember it's sine over cosine. So 0 over 1 is 0. 1/2 divided by the square root of 3 over 2 is square root of 3 over 3. Square root of 3 over 3, 1. Square root of 3, infinite because I'm dividing by 0. Okay, so that's what we do. So in this chapter, we're going to do the same thing over again, but instead of considering that I'm in degrees, we're going to consider that I'm in radians. Because radians make so much more sense than degrees ever did, right? 0, pi over 6, pi over 4, pi over 3, pi over 2. But the same memory aid applies. So pi over 2 is 90 degrees, 60 degrees, 45 degrees, 30 degrees, 0 degrees. So those are things that remember. And so how much of this is going to, okay. All right, so we come back to this thing called sine.
Okay. Don't worry about it.
Don't worry about anything?
No, that's good.
All right. So we have something that's 45 sine theta.
What?
Yeah, 45 sine theta. What's 45? The amplitude. Amplitude. So if I'm going to draw a sine function, the sine function goes like this, goes like that, plus or minus infinity. That's pi. There's 2 pi. But I go up to my amplitude, so if I have 45 sine theta, I got to go all the way up to 45, because that's how high it's going to go. It's going to go down to minus 45 up to plus 45. So now if I go A for amplitude, sine of bx. So I have something that looks like that. So A's amplitude, now I have something called period.
What?
That's, yeah, period. So, and the period is going to be 2 pi over b. So when I had 45 sine x, that sort of implies that my b was 1 and that my period is 2 pi. How much is 2 pi? 360 degrees. So I start someplace, I start going up, I go down, I come back, get back to the same spot, and then I start repeating. That's going to be 2 pi away.
Will be complete cycle.
That's one way to look at it. Yeah, complete cycle. Yeah. So if I have something a sine bx, then that's my period is going to be 2 pi over b. And sometimes I use a tau for period because it takes less ink. All right, so I've got 45 the sine of 1/2 x, and I want to graph that. Well, what I would do is I'd go and say, okay, well, it's a sine wave. It's going to go up, it's going to go down, it's going to go up, it's going to go down, it's going to go the other way. And then I'm going to say, well, it's going to go up to 45, it's going to go down to minus 45 because that's the amplitude, and the period is 2 pi over 1/2, also known as 4 pi. So now this is where 4 pi is, where it starts repeating. That's where 2 pi is, halfway. Over here is minus 4 pi. And then I'm done with my graph. Now, that sine wave looks exactly like the sine wave up here. Well, almost. Except where I'm numbering the axes at, right? So every time I draw a sine wave, doesn't matter what the amplitude or the period is, it's always going to look the same, and then I'm going to label the axes later so that I know what it is. Oh, yeah. What a wonderful thing to do. Okay, so now we have the cosine function. So I've got a cosine bx. A is again my amplitude. B is sitting there in front of the x, but my period is still going to be 2 pi over b. The difference is my cosine function starts off at 1. So when x is 0, I'm going to be at 1. I'm going to go down, I'm going to go up, I'm going to get back at 2 pi. I'm going to go down, I'm going to get up, I'm going to go back at 2 pi. So 4 pi. So 2 pi have a period, another 2 pi have a period. I'm going to go the other way too. So at minus 2 pi, I'm also going to be high. I'm going to have a maximum there. So I have a local maximum, a local minimum, things that we don't care about until calculus. But my period is going to be 2 pi over b. So if I have, I gotta say y is equal to 0.37 cosine 4x. All right, well, and I'm going to graph it. Okay, so I'll go graph it. My cosine function starts high, goes low, goes back up, goes back down, goes back up, does the same thing on the other side. And it goes all the way up to 0.37, goes all the way down to minus 0.37 because that is the amplitude. My period is 2 pi over 4, also known as pi over 2. So when I get to there, I'm at pi over 2. When I get to here, I'm at minus pi over 2. That's my period. What's half of pi over 2? Pi over 4. So at pi over 4, I'm now completely negative. At minus pi over 4, I'm completely negative. But it wouldn't have mattered what these numbers were in front of the cosine or in front of the x. My graph would have looked exactly the same until such time as I put an x and a y axis on it. Then it would look different. Now, that's all we need to talk about, so we'll solve some problems. Unless we've already solved them all, and then we'll just move on. Could do that too. So number 2. Y is 5 sine x. Okay, so my amplitude is 5. I don't have to write it down. I just remember that it is. Let's say that I had y is equal to minus 5 sine x. What's the amplitude of that? Da 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 da. What?
1? 1.
5, exactly. So the amplitude, if I have a sine x, my amplitude is going to be the absolute value of a. So don't be confused if there's a minus sign in front of it. All right, back to what we're doing. All right. So the amplitude is always a positive number. It's never a negative number. But it will have an effect on the graph. So I'll do 5 sine x first and then minus 5 sine x second. So we'll do 2 different curves. We'll do that one and this one. All right, so what we're going to do, I'm going make a sine function. Sine functions go up, they go down, they go up. They start at 0. We're going to pass here at 2 pi because my period's 2 pi. Pass there at pi. We're going to come up to a 5. We're going to go down to a minus 5. We could come over here and say that this is minus 2 pi, but we don't really have to. All right. Now let's say that we're going to do the other guy, minus 5 sine x. Well, that means when I'm positive, I'm negative, and when I'm negative, I'm positive. That's what that sign, minus sign, means. So the function turns around and goes the other way. Looks like that. Complicated enough? Oh, I hope so. Yeah, typically, yeah. All right, so we'll do number 4 next. Maybe we'll do number 4 next. There we go, well, we don't want to do it on graph paper, right? Number 4. Minus 4 cosine x. We have a question?
Yeah. I remember you should be able to plug these into calculators to find,
Oh, yeah.
what the graph looks like. I keep getting dimension mismatch.
Yeah. So if for example, your graphing calculators have a range in it, a default range for x and y. And so if your default range for y were to be plus or minus 1, for example, and you tried to graph something that was 4 cosine, then it'd give you an error because it can't get there.
Okay.
So you're going to have to open up the window to see it.
I did make I keep getting dimension.
Boy, that's pretty hosed, isn't it?
Am I just gonna make a quick
Well, I think it will. So we're doing y is equal to 4 cosine. I look at the period is 2 pi because the b is a 1 and it isn't there. I look at the amplitude's 4. So I go and I'm going to draw a cosine curve, but it's minus 4. So I'm going to start negative, and I'm going to go positive, and then I'm going to go negative, and then I'm going to go positive, I'm going to go negative. And I'm going to say that this happens at 2 pi, that happens at 4, and this happens at minus 4, and I'm all done. What do you mean, what?
Just like that.
Yeah, I know, it's that easy. That's all there is to it. All right, we're going to do 16.
Hold on.
Yeah. We'll do 16, and then we'll do 24, and then we'll do the next section. Number 16. Y is equal to 6 cosine 4 pi x over 3. Okay, so the amplitude is 6. The period is 2 pi divided by 4 pi over 3, which looks like 3 halves. So the period is 3 halves. All right, so, and this is a cosine curve. So the cosine curve is going to start at 6, go down, come back, go down, come back, going to go down to 6, minus 6, going to go down and back. And where does it repeat itself? 3 over 2. Where is it as 180 degrees? It's 3 over 4. Where does it cross that line right there? 3 over 8. Where do I cross that line right there? 1?
Yeah.
1?
Yes.
and this has to be
Quarter, isn't it?
half of this guy. No, it doesn't go. That doesn't go up 1. Oh, bummer. Hate it when that happens. 3 over 2. That's 3/8. So what's 3/8 plus 3/4? That'd be 1 and an eighth, right? 1 and 1/8 happens there. All right, so that's more than enough to do the thing. But now at my radians, there's no pi in my radian anymore because I had a pi in the other guy. Okay, 24. 24, y is equal to 240 cosine 120x. Now what would that make you think of, 120x anyway? Make you think of anything? I didn't think so. So my amplitude is 240 and my period is 2 pi over 120, which is pi over 60. All right. So this yeah, it's cosine. So I'm going to start high at 240. I'm going to go down. I'm going to come back up. I'm going to go down. I'm going to come back up. I'm going to go to a minimum of 240, and I'm going to start repeating at pi over 60. Right there, I have pi over 120. Over here, I have minus pi over 60. Oh, bummer. Did you guys really let me do that? What's wrong with the front row anyway? Erase, 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 erase. As I was saying, there is pi over 60, and there is pi over 120, and over here is minus pi over 60, and right there is minus pi over 120. That's much better. And this guy, what'd that guy be? Pi over 240. Okay, good enough? Okay, moving on to section 12-2. Okay, so I got something. I got y is equal to a sine. Sine what? Sine bx plus c. Okay, so that's the form of my equation. Or I got y is equal to a cosine bx plus c. Or I have y is equal to a cosecant bx plus c. Or I got y is equal to a secant bx plus c. I could have any of those guys, and it wouldn't matter. I could graph them all. All right, so I look at it and say, well, what's my amplitude? Well, my amplitude is A, but when we get to the cosecant and secant, which go to infinity, amplitude will have a slightly different meaning. We have a period. The period is going to be 2 pi over b, and then we have a phase shift. And the phase shift is going to be what? C over b. C over b. And there's some weasel words on 427, and I wouldn't worry about them. I would just say we're going to go one way or go the other way.
Thank you.
Okay?
People have it down a little bit after that.
And now you want to go. You got to. Half the class wants to go up. Half the class wants to go down. All right, so if all we do is remember that the amplitude is A and the period's 2 pi over B and the phase shift is C over B, then what? What's the matter?
Secant, the last one, y equals a what?
Yeah, secant. S-E-C.
Oh, S-E-C.
Secant. Oh my goodness. All right, so that being, now we know all those things. Now we can have y is equal to a
Is this a from or?
sine
No.
bx plus c plus d. Now what the heck is the d? We're going to have y is equal to a
No, that's not what D-
sine, cosine bx plus c plus d. What's the d? Oh well, I guess we'll get around to it. So my amplitude is a, absolute value of a for those that want to be that way. My period is 2 pi over b. My phase shift is c over b. And my displacement is going to be d. Now, what do I mean by displacement? Oh, I don't know. Let's see. Y is equal to 120 sine 60 pi x plus 45 plus 15. Okay, so that's what I got. So I got an amplitude of 120. I've got a period 2 pi over 60 pi 1 over 30. I got a phase shift of 45 divided by 60. What's that? 45 over 60. 9 over 12. 9 over 4. 3 over 4. I have a phase shift of 3 over 4. Okay? And I've got a displacement of 15. So that's what I got. And do I have a sine? So I got a sine thing. So up here, I've got 15. I draw a construction line. Okay. So my sine function is going to go up. It's going to go down. It's going to go up. It's going to go down. It's going to go up. It's going to go down. These all look about the same, right? It's going to go up 120. 120. So it's going to go up 135 is going to be my maximum. My lowest guy is going to be minus 105. 105. Oh, we're not starting there. That's right, I know. We're going to cross that point at pi over 30, but I got this guy here sitting here. So I have a phase shift, so I'm starting someplace else. So I'm going to ask myself, when is the sine 0? Okay, so I got 60 pi x plus 45 is equal to 0. 60 pi x is equal to minus 45. X is equal to minus 45 over 60 pi. Okay, so that's going to be minus 9/12 minus 3/4. Minus 3/4 with a pi on the bottom. Pi on the bottom? Should have been a pi there. Should have been a pi here. Should have been a pi there. All right. So that's where I'm gonna start this, not at 0, but at minus 3/4 divided by pi. Well, this is going to be, if this is pi over 30, then 3/4 divided by pi in the minus direction is way over here someplace, right? So the example is Hose City, and we better pick a better one. All right. So that's how we would do something like that. Do I worry about? No, I don't worry about the other trig functions until tomorrow, Wednesday. All right. So we're looking at number 2. Number 2. Y is equal to, now the real issue is, let's move back to that other problem. The real issue is this 45. That should be pi over 4. If that were pi over 4, then this would be pi over 4 over pi over 60. And these guys, the displacement would be 1 over 240. And the period is 1 over 60. So now that makes more sense. And I can, yeah. So we're going to, yeah, well, you should probably just delete that page and start all over, yeah. That was yeah, on a scale of 1 to 10, that was definitely a -3. All right, number 2. Y is equal to cosine x plus pi over 4. So the first question we ask ourselves, what is our amplitude? 1. What is our period? 2 pi. What is our what's it called? Phase shift. Pi over 4 divided by 1. Okay, so those are all the things that are known. I come and I draw the curve. And I ask myself, when is the argument 0? The argument is 0 when x is equal to minus pi over 4. Okay, so when I'm at minus pi over 4, I'm going to be the same as if I didn't have a phase shift. Okay, my period is 2 pi, so I'm going to be done there. Now that's not going to be 2 pi. 2 pi is 8 pi over 4. So this is going to happen at 7 pi over 4 because I have a phase shift going on. I got to go down. I got to come back up. This is somebody in between. So that'd be at 3 pi over 4 would be the in-between guy. I'm going up to 1. I'm going down to -1. And if I have to draw more than one cycle, I would draw another cycle, and then I'd add 2 pi onto the 7 pi over 4. So 8 plus 7 is 15. So I did 15 pi over 4. Now I have it drawn with 2 cycles, and isn't life wonderful? Okay. So the period is 2 pi over b, and the phase shift is c over b. That's what I'm remembering because I'm doing it today. Tomorrow I might not remember that, but today I'm going to remember that most of the rest of the day. Okay, so we're going to do number 4 next. I have 3 sine x minus pi over 3. I find that my amplitude is 3. My period is 2 pi, and my phase shift is minus pi over 3 divided by 1, also known as minus pi over 3. And I ask myself, when the argument is 0, x must be pi over 3. Okay, so now I've asked myself everything I need to ask myself. I'm now going to draw the curve. It's a sine function. It's going to pass through 0 at pi over 3. It's going to go up. It's going to go down. It's going to go up. It's going to go down that way. It's going to go up this way. It's going to come back. 1 period is 2 pi. That would be 6 pi over 3. So this would happen at 7 pi over 3. We'd pass through there at minus 6 pi, minus 5 pi over 3. Because that would be between there and there would be 6 pi over 3, which would be 2 pi. How high do we go? We go up to 3, we go down to minus 3. Okay. Next guy we'll do is 8. y is equal to minus sine 4x minus 2 pi over 3. Okay, so my amplitude is the absolute value of minus 1, which is 1. My period is 2 pi over 4, which is pi over 2. My phase shift is minus 2 pi over 3 divided by 4, also known as minus pi over 6. Minus pi over 6. I asked myself, for the argument to be 0, what must x be? All right, so x has to be pi over 6 for the argument to be 0. Okay, so now I'm all ready, except I don't remember if it's cosine or sine. So it's sine. I'm going to start at pi over 6. There's a negative sign going that way, so I'm going to be inverted. I'm going to go down, and then I'm going to go up, and then I'm going to go down, and then I'm going to go up, and I'm going to go the other way, something like that. I'm going to come down to minus 1. I'm going to go up to 1. And my period is pi over 2. Okay, so pi over 2 plus phi over 6 would be 4 pi over 6, 2 pi over 3. So this would be 2 pi, I don't think so, pi over 6 plus pi over 2. Pi over 6 plus 3 pi over 6, 4 pi over 6. Yeah, 2 pi over 3. All right, that'd be good. And am I done?
Yes.
Yeah, pretty much. I'd probably go the other way and say, what is this point? And so that would be at minus minus what? Minus 5 pi over 6, right? Minus 5 pi over 6. All right. One more and then go home?
Let's go home now.
Go home. Well, we ought to do number 24, really. Wait a minute.
That's all you need pretty much, right?
Yeah, pretty much. No, we're just going to go to 16. So we'll do number 16.
Okay.
Yeah, that'd be good. 16. Because we don't have to go that deep in the problem side. Y 4 sine pi over 6x minus pi over 3 amplitude. What's my amplitude? 4. What's my period? 2 pi over pi divided by 6, 12. What's my phase shift? Minus pi over 3 divided by pi over 6 minus 2. Okay, so when x is at 2, the argument is at 0. Okay, so I'm going to come down. That was really great for a set of straight lines, don't you think? So at 2, this guy negative or positive? At 2, we're going to start going up, and then we're going to start going down, and then we're going to come back. And that goes up to 4, it goes back down to minus 4. And the period is 12. So this is going to happen at 14. And over here at minus 12, it's going to go in. Oh, isn't that lovely? Okay, any questions? Draw sines, cosines, and sines, and curve, whatever. Yeah. It'll get better.
Got it.